Today's lesson 13, point 2, found on page 519, is all about box plots. All right, so our essential question, how can you use box plots to display data? The median is the middle value, or the mean of two middle values. So if there's an odd number, it's the middle one. If there's an even number, it's the two middle ones. When the data is given in order. The lower quartile is the median of the lower half of the data. And the upper quartile is the median of the upper half of a data set. All right, so here we go. In 1885, a pair of jeans cost $1.50. Today, the cost of jeans varies greatly. The chart lists the prices of jeans in several different stores. What are the median, lower quartile, and upper quartile of the data? So here's our data. These are the prices of different types of jeans in different stores. First, we're going to find the median by ordering them from least to greatest, which they've done for us. Then we'll find the lower quartile and the upper quartile. We're going to circle the middle number, which is our median. So our middle number is 42. All right, so $42. Now we're going to calculate the quartiles. Find the median of each half of the data set. So this 42 is not part of it. Okay, so this is now our lower quartile, the lower data set. This is now the upper quartile or the upper data set. And basically, all we're doing is finding the median of those two data sets, the median of this one and the median of this one. Okay, so find the median of each half of the data set. Notice 42 is not part of it. We have 24, 28, 32, 35. This is our lower quartile. As we work our way in, we have two middle numbers, so we have to take the average of these two numbers. Same with our upper quartile. There's no one middle number, so we have to take the average of the two. So we have 28 plus 32, which is 60 divided in half. And so 60 divided in half is 30. So the median of the lower quartile is 30. Okay, so what's the median of this? We have 50 plus 60 divided in half, because we're taking the average. That would be what, 110? Divided in half would be 55. All right, so the median is $30 in the lower quartile and $55. Whoops. So the median is, oh, no. I'm sorry. I read lower quartile and I got ahead of myself. Let's do this again. The median was this right here, the middle number. So the median is $42. The lower quartile median is $30, and the upper quartile median, let's get it on the screen, is $55. So in other words, there's a set of stores that sell jeans for roughly $30, and then there's another set of stores that we think of as a little more fancy, and their average price of jeans is $55. It's almost twice as much money. That's basically what we're figuring out. Okay, here we go. A box plot. A box plot is a type of graph that shows how the data are distributed by using the least value, the lower quartile, the median, the upper quartile, and the greatest value. Below is a box plot showing the data for the jeans prices from the previous page. So, remember 30, 42, and 55 were the critical numbers that we determined. This is the median of the lower quartile. This is the median of the upper quartile. And then with a box plot, and then this is our median, and that's where these 3 dots came from. But with a box plot, we also include the lowest number, which was, I think, 24. Let's look back. Yes, 24. And the upper number was, I think, 75. And so some people call this a box and whiskers. A box and whiskers. And the whiskers is the lowest number and the highest number. The box are all the medians. The median of all the data, the median of the lower quartile, and the median of the upper quartile. All right, let's do it one more time. Make a box plot. The data set below represents the ages of the top 10 finishers in a 5K race. Use the data to make a box plot. So the first thing we have to do is order the data from least to greatest. So 18 was the youngest. We've got a 19-year-old, 21, 23 it looks like, 23, 25, 33. Oh no, I missed 30. 30, 33, 35, and 38. So there's a 18-year-old kid and a 38-year-old grown adult, fully grown adult, in the same race. And they were the top 10 finishers. All of these people were the top 10 finishers. All right, so our median is, we have to work our way from the outside to the middle. Okay, so it's 23 and 25. So we have to, these two are in the middle. So we're going to go 23 plus 25 and then divide it in half, which is 24. So the median age is 24 years old. The lower quartile then is the median of the lower half of the data set. So I guess it doesn't include, okay, so it doesn't include this data. So we're gonna work our way in. So we go 1, 2. So we end up with 19 and 21, right? 1, 2, okay, yeah. 19 plus 21 all over 2 equals 20, because 19 plus 21 is 40, divided in half is 20. So this lower quartile median is 20 years. Now we have to figure out this upper quartile median. And again, our two middle numbers are 33 and 35, but they're not giving us space to do it. Not sure why, but that's all right. We can overcome. So we have, what, 68 divided in half, is that right? Yeah. So what, 34? All right, so the upper, oh, I should have figured that out. Halfway between 33 and 35 is 34. Okay. So the median for the upper quartile is 34 years old. Okay, so now we've got our number line. Okay, so now that we have our data, we can start our box plot. All right, so we draw a number line. Above the number line, plot a point for the least value, the lower quartile, the median, the upper quartile, and the greatest value. All right, our smallest value is 18. So 16, 17, 18, right there. Our greatest value was 38. So right there. Okay, we've done the least value, the lower quartile median, which was 20. The median, which was 24. The upper quartile was 34. Okay, so we've plotted all of our points. Draw a box from the lower quartile to the upper quartile. So you draw a box from the lower quartile to the upper quartile, like that. Inside the box, draw a vertical line segment through the median. Then draw line segments from the box, do the whiskers, out to the least and greatest values. There's our box plot. All right, so would the box plot change if the data point for 38 years were replaced with 40 years? Yeah, first of all, this would extend out to the 40. But it wouldn't change our median for the upper quartile because it's still 33 plus 35. So the upper quartile median would still be 34. So that's all it would do. It would just lengthen out the line for the greatest value. So yes, it would, I'm going to say the word stretch the line extending to the greatest value. Or this whisker right there would just get a little longer. That's the only thing it would do though. All right, let's take a look. What do we have? All right, so once again, let's do this one more time together. The scores of 11 students on a geography quiz. We have, let's see, okay, and they've already put them in order for us from least to greatest. What is our median? 86. So we have an odd number, so the 86 was in the middle. So now, okay, our lower quartile, oh, look at that, it's 78. That was easy. And now our upper quartile, 90. They're making it easy on us, not making us take those averages this time. All right, the lengths in seconds of 9 videos. Oh, so that's all we were supposed to do is just figure out the medians. All right, the lengths in seconds of 9 videos posted online. Okay, so this time they're wanting us to work for it. So we go 46 is our lowest. 50. Oops, nope, there's a 48. Sorry. Okay, so 48. 50. Another 50. 51. 53, 60, 62, and 65. All right, what's our median? So we have to go work our way. It's 51. That's the middle. Median of our lower quartile would be 49 because half of these two combined would be 49. And half of these two combined is 61. All right, so now let's do our box and whiskers, our box plot. Okay, so we have 48 right there. Oh, no, sorry. Just had a moment. All right, so 51, 49, whoops, 49, 61. Okay, so there's our box. Draw the line through the center median. Then we go to 65 for our upper quartile whisker. and 46 for the lower one, and there you have it. Okay, good luck.